Now, let us consider another type of sequence which is monotone sequences. That is monotone. Monotone sequences. What is monotone? It is monotone sequences means there are monotonically increasing and monotonically decreasing. Either it is monotonically increasing or monotonically decreasing. So, consider let x equals xn be a sequence of real numbers, or before going to that, consider sequence n. X equals sequence. What is sequence n? It is 1, 2, 3, 4, etc. So here it is x1, x2, x3, x4, etc. So you can say that this x1 less than or equals x2, less than or equals x3, less than or equals etc. Here it is actually x1 strictly less than, x2 strictly less than, strict inequality, not equality equality. So this sequence is said to be an increasing sequence. A sequence x equals x1, x2, x3, x4, etc. is said to be an increasing sequence only when x1 less than or equals x2 less than or equals x3 less than or equals etc. Such sequences are said to be an increasing sequence. Okay. So again you can consider another sequence, sequence 1, x equals sequence 1 by n, or y equals sequence 1 by n. Sequence 1 by n means 1, 1 by 2, 1 by 3, 1 by 4, etc. Okay. Here it is y1 greater than or equals y2, greater than or equals y3, greater than or equals etc. So f4, etc. So this sequence is said to be a decreasing sequence. So this is if a sequence x equals xn, that is x1, x2, x3, etc. are said to be an increasing sequence if x1 less than or equals x2 less than or equals etc. If x1 greater than or equals x2 greater than or equals x3 greater than or equals, then that sequence is said to be a decreasing sequence. Sequence n is where n is a natural number. X equals sequence n where n is a natural number, then this sequence is an increasing sequence. Here y equals sequence 1 by n where n is a natural number. In both of these cases, n is a natural number. Then sequence y is a decreasing sequence. Okay. So consider another sequence. Suppose x equals sequence 1, 2, 1, 2, 1, 2, etc. Whatever the nature of the sequence, is it increasing? Do you say that x1 less than or equals x2 less than or equals x3 less than or equals? No. Do you say that x1 greater than or equals x2 greater than or equals x3 greater than or equals? No. We cannot mention or we cannot comment about the increasing or decreasing of this sequence. So the sequence is, it is neither increasing nor decreasing. The sequence is neither increasing, it is not decreasing. Okay, it is neither increasing nor decreasing. Such sequences are also exist. Okay. Consider another sequence x equals a square, a cube, a power 4, etc. What is the nature of the sequence? So the nature of the sequence that is heavily depends upon the nature of this a, behavior of a. What is the behavior of the sequence? The behavior of the sequence heavily depends upon the nature of a. When a less than 1, a less than 1, so this is 1, a less than 1, what happens? So this is a s decreasing. A less than 1, what is this one? And when a greater than 1, this is the nature of or the behavior of the sequence heavily depends upon nature of a. If a less than 1, it is a decreasing sequence, and a greater than 1, it is an increasing sequence. Okay. So x equals a only, that's a constant sequence. Agree. So this is the increasing and the decreasing sequences. Okay. Now it is monotonically increasing and monotonically decreasing. Then there is a very important theorem that is related to this monotone sequence. The theorem is known as monotone convergence theorem. That's a very important theorem. Monotone convergence theorem. That's a very important theorem. So the theorem says that a monotone sequence, either it is monotonically increasing or decreasing, a monotone sequence of real numbers is convergent. Means monotone sequence of reals converges if and only if it is bounded. This is the first part. The first part of the theorem states that monotone sequence of real numbers converges if and only if it is bounded. Further, if x equals sequence xn, if x equals xn being a increasing sequence, x equals xn is increasing and bounded. If sequence xn is an increasing and bounded, then limit xn equals, then limit of xn equals supremum of xn where n fall in n. If the sequence is decreasing and bounded, this is also bounded, then limit xn equals infimum of xn where n is in n. So this is a very important research. This is some monotone convergence theorem. Theorem states that if x equals xn be a sequence of real numbers, then it converges if and only if it is bounded. That's a necessary and sufficient condition. Moreover, if sequence xn is a increasing bounded sequence, then what is its limit? Its limit is nothing but supremum of that sequence. If it is bounded below, means it is bounded and decreasing sequence, then the limit of that sequence is nothing but infimum of that sequence. Means the limit of a sequence equals its supremum only when it is increasing and bounded. The limit of a sequence is the infimum of that sequence only when it is decreasing and bounded below, and so. You agree? So that is the statement of monotone convergence theorem. How to prove this one? First, suppose that x equals xn be a monotone sequence. X equals xn be a monotone sequence. X equals xn be a monotone sequence means either it is monotonically increasing or it is monotonically decreasing. Monotone sequence simply. Suppose x equals xn be a monotone sequence, that means either it is monotonically increasing or decreasing. Whatever it may be. Then first we assume that the sequence is convergent. X equals xn converges. That's our first assumption. Convergence means immediately it is bounded. Why? Because we know that every convergent sequence is bounded. Every convergent sequence of real numbers is bounded. That's already a proved research. Every convergent sequence is bounded. Okay. So when x equals xn converges, surely it is bounded. There is no doubt. So first part is clear. For the reverse inclusion, this is the sufficient necessary part. Come to the sufficient part. For the reverse inclusion, assume x equals xn is bounded. Secant x equals xn is bounded. A bounded sequence, we know that a bounded sequence need not be convergent. That's proved by immediately using an example at x equals sequence. We know that a bounded sequence need not be convergent. Okay. So but here we assume that x equals xn is a bounded sequence. Then again assume, suppose this xn, secant xn is an increasing sequence. What happens here? Monotonically, there is nothing but a monotonic sequence. Then we say that, or we can assume that secant xn is an increasing sequence. So it is an increasing sequence, it is also a bounded sequence. Since xn is an increasing and bounded, bounded means it is bounded above also. What is a bounded? Sequence is bounded. The sequence is said to be bounded if it is both bounded above and below. Clearly the sequence xn is a bounded sequence, means it is bounded above as well as it is an increasing sequence. So the supremum of this sequence should be exist. So supremum of secant xn is exist. Let x star be the supremum of this sequence xn, where n falling in. Why? Because the existence of the supremum of the sequence is already established. Why? Because it is bounded above. So let x star equal supremum of xn, where n fall in n, then it should be exist. Let it be x star is denoted as x star. Now we have to show that this x star is nothing but the limit of xn. That is what we require here. Okay. So x star equals supremum of xn, where n fall in n. Since x star is the supremum, we know that x star minus epsilon is not an upper bound by the definition, not an upper bound of the sequence xn, where n fall in n for all epsilon is positive. Since epsilon is positive and x star be the supremum of sequence xn, surely or clearly we can say that x star minus epsilon is not an upper bound of xn. Then, therefore there exists some xk fall in sequence xn for all n fall in n, such that this x star minus epsilon less than xk less than x star. Okay, this is a familiar argument. This is so familiar with us. Since x star minus epsilon is not an upper bound, then there exists an sequence, xk in fall in sequence xn such that this xk lies in between this x star minus epsilon and the x star. Okay, so this is true for every n greater than or equals to. Okay, that means x star minus epsilon less than xn less than x star. Okay, that is x star minus, since it is true for every n greater than or equals k, you can replace this k by n. Sure. So it is x star minus epsilon less than xn less than x star. So again, since xn less than x star, since epsilon is a positive quantity, clearly xn less than x star plus epsilon also. Once, since xn less than x star, but epsilon is positive, surely xn less than x star plus epsilon. So combinedly, xn lies in between this x star minus epsilon and x star plus epsilon. That means modulus of xn minus x star strictly less than epsilon for all n greater than or equals k, and epsilon is positive. So that means this limit xn or as limit, that is means limit xn equals x star. Okay, limit xn equals x star. Limit xn equals what is x star? That is supremum of xn. So the first result is proved. Limit xn equals supremum of xn for all n following n. Limit xn equals x star means x star beats the limit, means it should be convergence. So the bounded sequence is convergence. So the reverse inversion is finished. Okay. Now there is another one case also arises there. Why? Because here we choose xn is an increasing sequence. Then check whether the sequence, check what happens there when the secant xn is decreasing. So when xn is a decreasing sequence, then that limit of that sequence is nothing but infimum of xn. That is what we require there. Okay, when xn is an increasing sequence, it is bounded, so it is bounded above, therefore its supremum exists, that it be x star. X star is supremum. Since x star is the supremum of the sequence, for all epsilon is positive, x star minus epsilon is not an upper bound. So we can find out an xk which lies in between this x star minus epsilon and x star for all n greater than or equals k. Okay, since so it is true for every n, so you can replace this k by n. So finally you will have this argument, that means mod xn minus x star less than epsilon, that is limit xn equals x star, but x star is a supremum of xn for all n following n. That means secant xn converges to that particular point. So when xn is a decreasing sequence, what happens there? That's our next consideration. Next we consider the secant x equals xn is decreasing. What happens? So for put a y equals minus of x. Minus x means, what is minus x? What is x? Secant xn. So what is minus x? Minus secant xn. So when x is increasing, when x is decreasing, secant x equals xn is decreasing. When x is decreasing, what is minus x? Surely minus x is increasing. Sure. Why? Because now that x1 less than or equals x2 less than, x1 greater than or equals, x2 greater than or equals, x3 greater than or equals, etc. This is a decreasing sequence. Okay. So you can means this a x1 greater than or equals, x2 greater than or equals, this is a decreasing sequence. Multiplying throughout by negative sign. So minus x1 less than or equals, minus x2 less than or equals, minus x3 less than or equals that one. So this minus of this one is an increasing sequence by definition. Clear? So when xn is a decreasing sequence, minus x is decreasing. So increasing, when xn is a decreasing sequence, minus x is an increasing sequence. Let it be chosen as y. Y is minus x. So y is an increasing sequence. Since y is an increasing sequence, so what is limit to y? When xn is an increasing sequence, then limit xn is supreme of xn. So when y is an increasing sequence, then limit of y equals supremum of yn or supreme of sequence yn, where n fall in n. But y equals yn. Yn means it is minus xn. That is supremum of minus xn, where n fall in n. Okay. So that means limit to what is y? Y means minus x. Limit to minus x, y is minus x. Limit minus x equals supreme of minus xn. What is supreme of minus xn? We know that supreme of minus xn is minus infimum of xn for all n following n. This is also a proved result. Okay. What is limit of minus x? Minus limit of x. So minus limit x equals minus infimum of sequence xn for all n following n. That means minus limit x equals minus infimum means what is limit x? Limit x equals infimum of xn. Limit xn, x means xn, so limit xn equals infimum of xn for all n following n. So that is the second result. Okay, thank you.